Up next in our module, we're going to be going over Matplotlib, the library that Seaborn is based off of. So again, Matplotlib is a library we can utilize to create powerful visualizations. It has a few differences from Seaborn. Visually, it can be a little more rugged, but it is just as powerful. It operates great with NumPy arrays and is very convenient to use because of its ability to integrate easily with Jupyter notebooks. To start using Matplotlib, we should again import the library using the command import matplotlib, and it is common practice to import the submodule pyplot because much of the utility of Matplotlib lies under the submodule, and we're going to be referring to this import as plt. Let's get into the functions we can use with our new library. The most basic of which is the plot function, and we can use it to visualize observations in a very simple way. Line plots will allow us to see the ways in which a set of data points correspond with each other, and we can throw in two arrays, one of which will be corresponding to the x-axis, while the other will correspond to the points on the y-axis. By default, the plot function will draw a line between the observations being plotted, and you can see to the right, we gave the function separate arrays with two observations in each array, and the plot will draw a point at 1, 3, and then 3, 10, and it will then connect the 2 points using a line. And you'll see that throughout this video, Matplotlib gives users tons of freedom in customizing the plots they generate. One of these customizations is to tell Matplotlib not to draw a line between the points and instead mark each point. We can do this by specifying in the function call the letter O as a string. A neat feature of the plot function is that we can leave out data points on the x-axis, and Matplotlib will fill it in with its default values. These default values will be a sequential array of values starting at 0 and going to n, where n will be the length of the passing array minus 1. So here you can see we successfully plotted a function. We successfully plotted the plot function with only the one-dimensional y points array, even though the plot visualization is in 2 dimensions. We can combine the concepts of drawing a line between points and marking observations individually with the use of the marker parameter. We can even customize these markers and deviate from the traditional O point or circle and instead use X's or fun little stars. And here is a chart of some of the marker symbols we can use, but the full list has around two dozen different symbols. And to customize our marker, we can simply fill in the marker parameter with our desired symbol. We can also further customize by customizing the style the line is drawn in by specifying the line style parameter. By changing this, we can draw dotted lines, dashed lines, or an alternating pattern of both called dash dot. And again, this is not the comprehensive list, and the full list has many more line styles. With all these customizations, we're able to tell the story. We're able to see the story the data tells in so many different and unique ways. So the plot function allows us to plot a set of data, but what if we want to compare plots side by side? So this is where the subplot function comes in handy. Subplot will allow us to draw many plots in a singular figure. And the function itself will take in 3 parameters: the number of rows of plots the figure will have, the number of columns of plots, and then the current plot number that we want to plot. So that can be a little confusing. So here's an example. Let's say we want to generate this plot to our right. It has 2 plots, and the dimensions of our entire figure will then be 1 row and 2 columns. So we're going to call the function and pass in the parameters 1 and 2, representing the dimensions of our figure. We're then going to pass in the number 1, meaning that whatever we plot is going to be in the first slot of our figure. You can see we successfully plotted our first plot. Next, let's call the subplot function again, but specify the value 2 in our third parameter. And now we have our completed subplot. And you can use this tool to generate as many plots as you want side by side. In this example, we're able to generate 6 plots. The entire figure would have the dimensions of 3 rows and 2 columns. If we want to customize our figure by adding a super title, we can do this by using the function's subtitle and specifying a string. Up next, we can use the scatter function if we want to visualize observations as individual points. You may be asking what's the difference between the modified plot function with no line and the scatter plot function. And the answer is that visually there is no difference and they're interchangeable. However, there is a conceptual difference. If you believe that the individual points should not be connected, you should opt to use a scatter plot. If it makes sense to connect the points, as in you believe that the distribution is going to be continuous, then you can opt out and use the line plot instead. Scatter plots are fairly easy to use. You just throw in your two arrays, but they must have the same length. Let's get into some of the functions that share similarities to some plots we went over in Seaborn. First up is the bar plot function. And as a reminder, bar plots are going to be showcasing distributions of categorical data. And it takes in two arrays. In a Matplotlib, you throw in an array of labels on your x-axis, while the second parameter will be the value of each bar. And just like Seaborn, we can generate histograms in Matplotlib to showcase the distribution of a numerical variable. To generate a histogram, we can call the hist function and throw in one parameter, which should be an array. And Matplotlib will then do the hard work for you and divide the plot into parts and count the number of array values that fall into each part. For the sake of convenience, we generated an array of random values as our array. You can see how the function will take care of plotting for you. A really neat feature of Matplotlib is the ability to create pie charts. Pie charts are great if you want to visualize a proportion of each observation. So let's say you and your friends raise money for a fundraiser and want to visualize the difference between how much each of you raised. Pie plots are a great candidate for that. The function will take in an array, and Matplotlib will determine the size of each wedge using formula you see here. We can even label each wedge by specifying in the labels parameter, which should be another array of the same length. Here we label the wedges based on the count of each fruit. Super neat feature of the pie chart is the explode feature, which will allow us to highlight a specific wedge in the plot. This can be done by specifying in the explode parameter an array of equal length where each value will correspond to the distance you want each wedge to explode out of the plot. And as I said before, this slide deck is by no means a comprehensive overview of all the utilities in Matplotlib. It's such a powerful tool. It even has some cool three-dimensional plotting ability. And it's so easy to use, especially if you're already using Jupyter Notebook. The library gives us access to modify our plots in so many different colors, line styles, dot sizes, opacities, and many, many more. But hopefully this can get you started in using Matplotlib to visualize your data.